Welcome back, everyone. In this video, we're going to create another practical application. Since we've now learned how to work with files, let's go ahead and create a practical application and use what we've learned in files and some more. We're going to create a file splitter and file joiner. So if you have a file that's sizable, you can split it into smaller pieces, and there will be the joiner component that's going to take those small pieces and join them together. Let's go ahead and get started. I'm going to create a brand new Python 3 notebook. And since the last one was, I believe, 016, I'm going to make this one be 017. I'm going to call this splitter joiner. Let's understand what we're going to be doing overall. We're going to create a couple of methods, a couple of functions, one that splits, one that joins. And we're going to be feeding the file to this splitter joiner method. We could ask the user, of course, to give us the file, but we're going to skip that. We're just going to assume that we have a particular file that we're hard coding in there. Clearly, we could just use an input to ask the user for a file to be inputted, and then split that and join that. I'm interested in getting the functionality going and then making it nice later when we learn more advanced Python topics. So let's go ahead and start writing. I'm going to call this splitter joiner. I'll do a shift enter. I'm going to create my splitter, def splitter, and I'll do a shift enter for the time being, and I'll do a def joiner, which we're going to write in just a little bit. So let me go up here and start writing it. I'm going to start with a buffer size variable, which I'm going to set to 10,000, or let's say 100,000. Let's make it actually a million. Remember, this is in bytes, as you recall from before. I'm going to have an input file, which I'm calling infile, and this is going to be opening a file called wildlife.wmb. Now, I did a search on the web. If you take a look, I just did wildlife.wmb download, and the very first one, which goes to archive.org, allows you to download it. This was a default video file in Windows. You can go here and download. I downloaded the Windows Media version of it, and I placed it in my Python folder. So here is wildlife WMB, and if I were to play it, see a bunch of horses running, etc. It is, it's a good size. It's about 25, just over 25 meg in size. So it illustrates that if I wanted to email it with many mail servers, they still have a 20 megabyte file limit. I couldn't, but I could email, let's say, the pieces, and then have the other end join those pieces together. So I'm going to open up wildlife.wmb. The extension is important, and this is a binary file, so we're going to use RB for reading binary. I do want to remind you again that Python is case sensitive, so this wildlife, you need to spell it out exactly the way it is in the file right here. I guess it's capital W, so I'm including a capital W. I'm going to have a file prefix right here, and for the sake of consistency, let me go ahead and make this an in file like that. And I'm going to set that equal to just let's say wildlife. I'm going to have a buffer variable, which is going to be my in file, and I'm going to read the buffer size. So I'm going to read 1 million bytes and dump it of the file and dump it into this variable buffer. I will have an index variable of 0, and we're going to use one of the few times we'll be using a while loop. I'm going to do while length buffer. And what this says, when you do a while length buffer, it checks to see if there is something in the buffer that is not equal to 0. You may recall in one of my earlier videos, I showed you what things evaluate to true and what things evaluate to false, and I went over a bunch of things that always evaluate to false, and one of them was 0. So while a length buffer is not 0 in effect, this is going to be a true statement, and what's in the while loop will execute. So while there's something in there, I'm going to take my file prefix and I'm going to append to it this string version of I. And these are going to be my little pieces. This is the same as saying file prefix is equal to file prefix plus string of I. This is just a shorthand notation. So these are going to be my pieces. Right now I have a file prefix variable, so this is going to become wildlife0 to begin with. I'm going to have an output file, which is going to be equal to open an output file with this particular file prefix that I have for writing binary. And I'm going to take that out file and I'm going to call its write method and write those 1 million bytes that we read. And then we're going to take out file and close it. So that file is closed. I'm going to print a little dot as an indicator that something was done. I will end it with nothing, so it's printed on the same line. This is going to be our progress bar. Okay. I will let my buffer be equal to my input files read the next, the pointer has moved at this point, you may recall. I'm going to read the next 1 million bytes and I'm going to increment I by 1. I will let the file prefix be reset to wildlife so it's consistent. And outside of the file, the while loop, I'm going to take my input file, which is what's pointing to that original video, and I'm going to close it. So we're clean. Have a print statement and then do a print files, split it. Very straightforward program, actually. If I were to do a shift enter here, we should get a bunch of dots running, assuming I don't have any error messages. Okay, let me see, that didn't work for some reason. Let me try doing this again. Oh, I'm not calling it, silly me. I apologize. So that actually creates, so let me add a cell here and I'm going to call splitter. There we go. So it says file split it, proof is in the pudding. Let's go ahead and bring up our folder, that's Python. And there I have wildlife 0, 1, 2, 3, etc. all the way to 26 apparently. You notice other than the last one, all of them are fairly consistent, 977 kilobytes, which is basically 1 million bytes. And remember that the operating system uses powers of 2, so if I want to be very precise, 1000 is 1024 bytes is actually 1 kilobytes, for instance. I just went with a nice round number. So we have these pieces of the file. Now we'd like to go ahead and write the joiner portion of this that joins these files together. So I'm going to take an output file and I'm going to set this equal to open new wildlife.wmb. I don't want to override my old ones, I'm just doing it like this. Now, important as the mode is going to be append binary, not write binary, because if you do write binary, every time you write a piece, it overwrites the previous piece. We want these pieces, 0 through 26 that you just saw, to be appended together. So we're going to open the file for appending binary. As before, I'll have a file prefix of wildlife. Okay, I'm going to have my input file be equal to open the file prefix plus string of 0. I know that's the very first one, and this is for reading in binary mode. So I read the first piece, and I'll let buffer be equal to the input files read method. So this is the handle. This is going to point to the first one, and then I'm going to read everything, which is the 1 million. I is equal to 0, and then we'll do our while loop. So I'm going to say while length buffer. So again, while there is something in the buffer, and currently there is, I'm going to take my output file and I'm going to call the write method, and I'm going to write out whatever is in the buffer. I'm going to print a dot, which again you recall is basically our progress bar. So we're going to do that. I'll increment I by 1. In this case, and this is a bit clumsy to do it, I've sort of cheated, and I know, how many pieces I have. I have 26 pieces. So I'm going to say I have an I statement, and I'm going to say if I is equal to 26, then break the loop, exit the loop. We don't need to be in it anymore. I'm going to let the file prefix be equal to wildlife again. I'm going to take the file prefix and increment it, basically. Just plus equal and the string of I. So it's going to become 1 at this point, or 1 attached to it. I'm going to take my input file and set this, input file, and set this equal to open the next file prefix for reading binary, and I'll let the buffer be equal to input file that read everything. Outside of the loop, I'm going to take my out file and close it. I will print and print a last statement that says files rejoined. Okay, let's do a shift enter here. No errors, which is a good thing. Let's go ahead and call joiner and do a shift enter, and it's running through. Boom, boom, boom. It says files rejoined. Let's see if in fact we have something called new wildlife, which we do. Let's see. So notice it's for some reason it's a little bit smaller than this one, so it makes me wonder if I made a mistake in it. Let me go ahead and right click and delete this. It appears to me that my counting was incorrect. If I is equal to 27, because we're counting from 0 to 26, and that was my mistake. So I'll do a shift enter again, and I will run the joiner again and see what we get. Let's see. Okay, so notice because I ran it twice, it appended it to itself again, so I'm going to have to delete this again. Okay. It did it too fast, and I thought it didn't run, when in fact it ran. So the program seems to be working fine. I'll do a shift enter. It's running very quickly. I'm not sure why I ran the first time a little slow. You notice it is now the exact same size. I'm going to double click this, and the files have been rejoined, as you can see. Beautiful. So this illustrates the fundamental concepts. Obviously, it's a bit clumsy doing it this way. We can make it a little bit more interactive, and we will do that in the next video. Thanks as always for watching, and please share if you're enjoying these with loved ones and friends, and see you in the next video.